All right, today's quick lesson in algebra is about point, slope, and standard forms of linear equations. We've already looked at slope-intercept form. Remember, slope-intercept form is y equals mx plus b, but did you know that there are two other ways that you can write the equation of a linear function or a linear equation? There's a form called point-slope form, and then there's a form called standard form, and we're going to talk about both of those things right here very briefly. We're just going to touch upon them. So let's start with point-slope form. So point-slope form looks like this. We have y minus y sub 1 equals m times the quantity x minus x sub 1, where, of course, we've talked about this before, m is the slope, okay? And then you have the coordinates of 1 point on the line. So if you know 1 point on the line, or the coordinates of 1 point on the line, and you know the slope of the line, you can write an equation of that line in point-slope form. And the coordinates of that point on the line is x sub 1, y sub 1. Notice that the x sub 1 and the y sub 1 are both being subtracted, right? So we have x minus the coordinate x sub 1, and we have y minus the coordinate y sub 1. So at times, if the coordinate is negative, we're going to need to remember that we're subtracting a negative, which means that the sign is going to change inside. Let's take a look at how we can, if we know the slope of a line and we know the coordinates of 1 point on the line, we can write an equation in point-slope form. In my opinion, this is the most underutilized form of a linear equation. It's one of the simplest to generate. So as long as you can remember the form, then it becomes easy to write the equation. Let's take a look at a few examples. Write the equation in point-slope form of the line, which has a slope of 3 and goes to the point 2, 3. So we know the slope is 3, m equals 3, and we know it goes to the point 2, 3. So x sub 1 is equal to 2, and y sub 1 is equal to 3. All we need to do is replace those three numbers in for y sub 1, m, and x sub 1, and we've got our equation. So it goes y minus the y sub 1, which is 3, equals m, which we know is 3, times the quantity x minus x sub 1, which is 2. So there it is. Pretty easy. Let's look at a couple more. Write the equation in point-slope form of a line, which is a slope of 1/2 and goes to the point -1, -6. So we know m is 1/2, we know x sub 1 is -1, and we know y sub 1 is equal to -6. Again, we're just going to replace those three values into our point-slope form, and we get y minus -6. So when we have minus a -6, okay, I'll write this step down. So it looks kind of like this. Y minus -6 equals m, which is 1/2, times the quantity x minus x sub 1, which is -1. So we got this kind of thing going on. Now, we don't usually leave it in this form. Instead, what we do is we change all the minus negatives to plus, and we rewrite the equation kind of like this. Y plus 6 equals 1/2 times x plus 1. Now, what that tells you then is that if you see a plus sign, right, if you see the pluses in your point-slope form, then you know that the x and y coordinates are going to be negative because subtracting that negative turned it into a plus. Speaking of that, let's look at one more. It says identify the slope and 1 point on the line with the equation y plus 2 equals 3/4 times the quantity x minus 5. Well, let's start with the easy part, the slope, right? So we know the slope of this line is 3/4. But what are the coordinates of the point? What are x sub 1 and y sub 1? So remember, x sub 1 is what's being subtracted from the x, and what's being subtracted from the x is 5, so the x coordinate is 5. And the y coordinate is what's being subtracted from the y. Now take a look at that. We have y plus 2. So how did we get from a minus to a plus? Well, your y coordinate must have been negative, right? Because subtracting a negative changed it to a positive. So the coordinate of the y is -2. So that's writing an equation in point-slope form. It's simple though. Remember the point-slope form tells us one point and the slope, but it doesn't necessarily give us the same information as the slope-intercept form. For example, what if we were given an equation of a line in point-slope form and we were asked, hey, what's the y-intercept of that line? Well, remember that's b, right? So we need to convert it to y equals mx plus b form. Pretty simple to do. All you need to do is distribute through the parentheses and then add the constant with the y to the other side, right? So for example, in this one, we're going to distribute the 3, and then we're going to add that 2 to both sides, and we get y equals 3x minus 13. And now it's in slope-intercept form, y equals mx plus b, and you could tell me what the y-intercept is. Let's try another. Distribute through, y plus 4 equals negative 2x minus 6, and then we're going to add or subtract a constant from both sides, right? And we get y equals negative 2x minus 10, and suddenly we know that negative 10 is the y-intercept. One more. This one involves a fraction. Not that big of a deal. 1/2 x minus 1/2 times 5 is 5 halves. So we're going to add 1 to both sides. We get y equals 1/2 x. So we have negative 5 halves, and I'm going to change that 1 to a fraction that has 2 as its denominator, so that's 2 over 2. So negative 5 over 2 plus 2 over 2 is negative 3 over 2, and now I know that the y-intercept is negative 3 halves. Don't forget about those special case lines, right? So just a little bit of review with our horizontal and vertical lines. Horizontal lines have the equations in the form y equals b, and vertical lines have an equation in the form x equals a. X equals a, where a is the x-intercept, and of course b in the horizontal line is the y-intercept. That's point-slope form. Standard form is yet another form of a linear equation, and we'll talk about this one in a little bit more detail as it relates to graphing. But we're going to take a look at two things here. Standard form is good when you want to know what the x and the y intercepts of the line are. It's actually easy to find. So if you need to find 2 points on the line, with a line that's written in standard form, the easiest thing to do is to find the x-intercept and the y-intercept. And so what I've done is I've broken down the process of finding those two things into very simple steps. So let's find the x-intercept first. Remember, the x-intercept is the point on the x-axis where the line crosses, and every single point on the x-axis is going to have a y value of 0. It's going to have a y coordinate of 0. So to quickly find the x-intercept, all you have to do is put 0 in for y and solve the resulting equation for x. And likewise, if you're finding the y-intercept, every point on the y-axis is going to have an x-coordinate of 0. So we replace the x with a 0, and then we solve our resulting equation for y. It actually goes quite fast, and I'm going to show you why it goes really fast. So let's take a look at an example how we can find the x-intercept and the y-intercept on the line with the equation 3x plus 2y equals 12. So I'm right here. All right, so remember, if we're finding the x-intercept first, it doesn't matter really which one you do first, we're going to find the x-intercept first. So we're going to replace y with 0. And when you replace y with 0, you get 2 times y with 2 times 0, which is 0. So really what ends up happening is this entire term cancels out, right? Cancels out. So we end up with the equation 3x equals 12. 3x equals 12, and if we solve that for x, we get x equals 4. So our x-intercept is x equals 4, or the point 4, 0. To find the y-intercept now, you replace the x-coordinate, or the x in the equation with 0. So what happens is this term completely disappears, and we're left with the equation 2y equals 12. We solve for y, and we get y equals 6. So this is the y-intercept, The y-intercept would be at the point 0, 6. So we know 2 points on this line just by finding the x and y intercepts. And that's going to come in handy in the next section when we are graphing lines in standard form. All right, so the last thing we need to do is be able to convert equations that are in standard form to slope-intercept form. So remember, we want to go from standard form, which is ax plus by equals c, down to y equals mx plus b. So essentially what we're trying to do is we're trying to isolate y. And there's only a couple steps to do that, actually. If we're trying to isolate y, we need to move the x term to the other side by adding or subtracting it. And then we're going to rewrite what we have. And then we're going to divide both sides by the coefficient of the y term. So if we look at a few examples here, let's look at the first box, 2x plus 3y equals 6. We'll take that same one we used before. So for step number 1, we're going to subtract the x term from both sides. So we get 3y equals, now this is where you need to write it in mx plus b form. So we do need to make that x term first, okay? So we get negative 2x plus 6. And then we need to divide, step number 2, divide both sides or every single term. All right, let's remember we need to divide every single term by the coefficient of y. So we get y equals, now take a look right here. We do not need to do anything with this, just leave it as a fraction, negative 2/3 x. And then we're going to simplify, if we can, the other fraction, which we can in this case, to plus 2. So now it's in slope-intercept form, and we can identify the y-intercept and the slope of that line, even when it wasn't originally in this form. We're going to do a couple more, and then we're going to call it good. So again, we're going to add or subtract the x term to both sides. In this case, I added to undo it. So we got negative 2y equals. Now remember, we do like to have that x term first, right? So 4x plus 5. And then we're going to divide every term by the coefficient of the y, negative 2, negative 2, negative 2. And we get y equals 4 divided by negative 2 is negative 2x. And then 5 divided by negative 2, we can leave that as the fraction, and it's going to be negative, so negative 5/2. That's our y-intercept. One more. So we're going to subtract the x from both sides. That leaves us with negative y equals, again, let's put that x term first. So we get negative x plus 5. And then remember the coefficient of that y in this case is negative 1. Let's just remember that, negative 1. So we're going to divide every term by negative 1, negative 1, negative 1. And it's going to make those go away, and we get y equals, let's see, a negative x divided by negative, that's positive x. And then 5 divided by negative 1 is negative 5, so we get minus 5. And this is how you convert a linear equation in standard form to an equation in slope-intercept form, which then can yield other information about the line, like the slope and the y-intercept. So the goal here was for you to be able to write a linear equation in different forms. We already spent a lot of time with slope-intercept form, but we looked at 2 other forms, the point-slope form and the standard form here. We didn't do a lot of writing in standard form, but that's because we don't really write a lot in standard form. But standard form will come in handy in our next unit on systems of equations, so it is important that we understand the basics of what it actually looks like. Hope you found these lesson notes informative, and